By now, it should be apparent that condensation is a continuous process beginning when water vapor condenses onto hygroscopic nuclei at relative humidity as low as 70%. As the relative humidity of the air increases, the visibility decreases, and the landscape became masked with a grayish tint. As the relative humidity is gradually approaches to 100%, the haze particles grow larger, and condensation begins on the less active nuclei. Now, water is condensing onto a large fraction of the nuclei. As water condenses onto them, the droplets grow even bigger until eventually they became visible to the naked eye. The increasing size and concentration of droplets further restrict our visibility. When the visibility lowers to less than 1 kilometer and the air is wet with countless millions and millions of tiny floating water droplets, the wet haze becomes a cloud resting near the ground. And this situation we called it fog. With the same water content, fog that form in a dirty city air like is thicker than fog that form over the ocean. Normally, the smaller number of condensation nuclei over the middle of the ocean produces fewer but larger fog droplets. City air is with abundant nuclei produce many tiny fog droplets, which greatly increase the thickness of the fog and reduces our visibility. So the fog that form in polluted air can turn into acidic, and it is the tiny liquid droplets combined with gaseous impurities such as oxide of sulfur and nitrogen. So acid fog is harmful for our health. As tiny fog droplets grow larger, they become heavier and they tend to fall towards the earth due to the gravitational force. A fog droplet with a diameter of 25 micrometer settles toward the ground at about 5 centimeter each second. At this rate, most of the droplet in a fog layer is approximately 600 feet thick would reach the ground in less than an hour. So therefore, the questions arise that how does fog actually form and how is fog maintained once it does form? Fog, like any clouds, usually form in one of two ways. Number one, by cooling. Air is cooled below its saturation point. We call it dew point. So by cooling is the one reason. And the second reason is by evaporation and mixing. Water vapor is added to the air by evaporation and the moist air mixed with relatively dry air. Once the fog forms, it is maintained by new fog droplets, which constantly form on available nuclei. In other words, we can say the air must maintain its degree of saturation either by continual cooling or by evaporation and mixing of the vapor into the air. So the next we'll be talking about different types of formation of different types of fog.